Okay, so this lesson is going to go over properties of exponents, which you've seen some of in Math 1. They're not difficult. You just need to make sure that you pay attention to which one is which. So we're going to go over a couple of them, do some examples. The expectation when we do these video lessons is that you are following along, taking notes as if you were in class, working through the examples with me as if you were in class, um, and then completing your homework afterwards. A couple times, depending on kind of where you're at, how you feel about the material, it might be smart once we go over everything. If you want to pause the video, try and work through a couple examples on your own, and then check and see how you did, since obviously I'll work through them all with you. So anyway, okay, so starting with the properties at the top. The first one is product of powers property. So basically, you'll hear me say a lot when you multiply, you add. So a to the m times a to the n. The a is your base. That's the same. If your base is the same, you're going to add your exponents. So let's say you were given like a to the fifth times a to the third. Sorry, that's kind of sloppy. Because you're multiplying and a is your base and it's the same, it's a to the eighth because you're going to add your 5 and your 3. Okay, whereas if you have something like the next one, power of a power property, you only have one base there and it's a power to a power, so m to the n. Then you multiply. So using that same example from above, let's say you have a to the fifth to the third. Sorry, that's really sloppy. You would get a to the 15th because 5 times 3 is 15. So when you have two bases that are the same, you add. When you have one base and two powers, that's when you multiply. Okay. Now, if you look at the power of a product property, here we have two different bases. We have an a and a b, but they're both being raised to the same power, that m. So you want to think about the distributive property. I think I distribute the exponent to the a and to the b. So let's say you had, I don't know, a, b to the second. That would end up being a squared times b squared. Okay, so they both bases get that exponent. Power of a quotient property, it's the same idea as the power of a product property. Now you have a divided by b to the m, but again, you have two different bases raised to the same exponent, so you're kind of distributing again to both. So let's say that you had a over b to the ninth. That's just going to be a to the ninth over b to the ninth. And these properties are, you're going to have more than one in one problem. So let's say we had like a to the second over b, and that all raised to the third power. Well, then you would have a to the a to the second to the third. So then all of a sudden you're taking that power of a product property and the power of a power property. So you're going to get a to the sixth, because 2 times 3 is 6, all over b, and that's technically to the first, so b to the third. So sometimes you're going to get these properties that are mixed together, and you just have to use 2 and 1. Okay. If you're dividing, so a to the m divided by a to the n, you have the same base. So this is similar to the first one. Here we have the same base with different exponents, but we're dividing. So you subtract. So multiplication and addition go together, and division and subtraction go together. So let's say you had a to the 12th all over a to the 4th. Then you would end up with a to the 8th because it's a to the 12 minus 4. Okay. The negative exponent property, you never want to leave negative exponent. So basically, if you have a negative exponent and it's in the numerator, you need to move it to the denominator. If you have a negative exponent in the denominator, it moves to the numerator, and then it becomes positive when you do that. So let's say you have a to the negative 7th. To make that positive, it would be 1 over a to the 7th. And then let's say you had, I don't know, let's say you had 3 over b to the negative 4th. To make that positive, the 3 stays where it is, and you're going to move b to the 4th up in the numerator. Well, since the 3 is already in the numerator, it's just 3b to the 4th. Okay. This last one is the zero exponent property. Just remember, anything to the 0 power is always going to be 1. So I could put anything here. I can put 1 million to the 0 property, and it's going to be 1. Okay, so no matter what it is, if it's to the 0 property, it's 1. So we're going to work through a couple of these. The biggest thing I would say if you're struggling with these is you take a look at the problem and you go back and you look at the rule and say, okay, well, which one does this look like? So if you look at number one, we have a to the third times a to the seventh. Well, that looks like the very first property, the product of powers property. So that's the rule you're going to apply. So here we have the same base. So you're going to multiply and add your exponent. So you get a to the 10th. This is to the 0 power. Anything to the 0 power is always going to be 1. Okay, so here this is kind of what I was talking about with the power of a product property and power of a quotient property. Here we have different bases raised to an exponent, so you're going to distribute that exponent in. So we have x to the third times 3, because then essentially you're working with the power of a power property. So you're going to get x to the 9th, because 3 times 3 is 9, and then y to the third, because remember that's really a 1 there, you guys, so 1 times 3 is 3. Here, this is your power of a quotient property, quotient of powers property. So you're dividing, you have the same base, so you're going to subtract your exponents. So x to the 10 minus 7 is 3. Okay. Here you have the same base. Here it's just a number instead of a variable. So this is going to be like your very first rule. 2 to the 4th times 2 to the 5th is 2 to the 9th, because 4 times 5, or I'm sorry, 4 plus 5 is 9. So since you have the same base there, even though it's a number instead of a variable, all of the same rules apply. Okay, now when you have this, you can take it the next step farther, and it really won't take you much if you grab your calculator and say, okay, well, what is 2 to the 9th? In this case, it's 512. So you can finish that off and say that's 512. So this is applying the property, and then that's your actual answer. Okay, so if you're feeling at this point like, okay, I'm starting to get it, this would be a good time to pause the video, work through a couple, and see how you do. Just hit play and then see what my answers are. Just work through as many as you can until you get stuck, and then obviously that's a good place to check your work. Okay, number 6 is a lot like number 4. It's division, and we're subtracting. You have the same base here, so 8 minus 3 is s to the 5th. Okay, here this is a power of a power, so we're going to multiply. So 2 times 6 is x to the 12th. Whereas conversely on number 8, now we have 2 of the same bases and we're multiplying, so we are going to add our exponents, so you get x to the 19th. Okay. Number 9 is a lot like number 6. However, when you do number 9, we've been doing numerator minus denominator, so that gets you x to the negative 6, because 7 minus 13 is negative 6. But remember, we don't want negative exponents, so what you're going to do is you're going to take that. Remember, you guys, that's really x to the negative 6th over 1. So you're going to take that and move it down into the denominator, and that's really going to be 1 over x to the positive 6th, and that would be your final answer. Okay, you don't want to leave things with negative exponents. Here in number 10, the first thing you do, even though you see negative exponents, apply the other property first, your power to a power property, because you're going to multiply here. So negative 2 times negative 4 gets you 3 to the positive 8, and then you don't even need to worry about moving a negative exponent because it works itself out. 3 to the 8th is 6,561. Okay, sorry, whoa, getting a little sloppy here. Okay. Same thing with number 11. It's a lot like number 10, but now you're dealing with positive exponents. So 6 times 3 is 18, so you get 2 to the 18th. So that would be applying your properties. And then when you actually figure out 2 to the 18th, it's 262,144. Okay. So obviously, if you didn't have a calculator handy, 2 to the 18th would be an acceptable answer. If you did, then I would expect you to finish it off. Okay. For number 12, that's a negative exponent. That's the only thing going on there. So you're just going to apply your negative exponent property, and it's going to be exactly like number 9, actually. That's a coincidence I didn't realize. And it's going to move to the denominator, 1 over x to the positive 6th. Okay. Number 13 is just like number 9. You're going to subtract, and you end up with g to the negative 2nd, because 3 minus 5 is negative 2. So you move it to the denominator, and you get 1 over g to the 2nd as your final answer. For number 14, this is kind of what I was talking about when I was explaining the properties. You are going to use your distributive property idea with the power of a product property, but you already have some of your exponents in there. So when you distribute that in, you're going to get a to the second, but to the third. So 2 times 3 is 6, and then b to the fifth to the third will power to power you multiply, so to the 15th. Number 15 is just like number 12. You're going to move it to the denominator 1 over p to the fifth. That's your final answer. All right, number 16, you guys, this is the same thing. You're multiplying, multiplying, multiplying. We've just only seen it with things like number 8 or number 1 where you have 2. You have the same base in all three of those, x to the third, x to the fifth, and x to the eighth. So you're just going to add them across the board. So that's going to be x to the 3 plus 5 plus 8. That's how you want to think about it. It's the exact same thing whether you have two terms you're multiplying or whether you have 3 or 4 or whatever. So you're ending up with x to the 16th there when you add those all together. Okay. For number 17, that's a negative exponent similar to number 12, similar to number 15, and you're going to end up with 1 over 5 to the third. And then again, that's applying the properties, so you end up with 1 over 125. Cool. For number 18, again, I would do negatives last. It just makes your life a lot easier because a lot of times they go away or become a little bit simpler than dealing with them on their own. Here we have the same base, which is 3. So when we multiply, we're going to add our exponents. So you end up with 3 to the negative third plus negative 7. So that ends up being 3 to the negative 10. So we still have a negative to deal with, but at least here, now you have a negative to deal with, and it's only one negative, whereas you started with 2. So that's going to become 1 over 3 to the 10th when you apply that negative property, a negative exponent property. So you end up with 1 over 59,049. Okay. For number 19, you're doing the same thing as number 14. You're just going to kind of distribute that 4 in. So you get 2 to the 3 times 4, which is 12, a to the 0 times 4, which is still 0, and d to the 5 times 4, which is 20. So this right here, you guys, becomes 1. So if you're multiplying by 1, it's not going to change anything. And your 2 to the 12th is going to become 4,096 times that 1, which isn't going to do anything, times d to the 20th. So that's your final answer. Okay, and the last one here, we have 3 to the third over 3 to the 6th. So this is similar to 13. Number 9, number 4, you're going to subtract. So you end up with 3 to the 3 minus 6, which is negative 3. So now you need to apply your negative exponent property. So 1 over 3 to the third. And then once you're done applying your properties, just clean it up, and that ends up being 1 over 27. Okay. All right, so those are pretty much all of the properties. I went through them kind of quick, so if you need to watch it again, please do. That's why we made it a video, so it's always available to you if you need to watch it again and hear another explanation. If you could flip to the back of your notes, we're just going to really quickly go over your Pythagorean theorem. So you guys, this is something you did in 7th grade. But just to refresh your memory, your Pythagorean theorem is used to find the sides of right triangles. That's important to remember. A lot of people try and use Pythagorean theorem for anything, but it's right triangles only. Okay, so remember your Pythagorean theorem is a squared plus b squared equals c squared, and c is always your hypotenuse, which is the longest side. Okay, hopefully that's ringing a bell for you. So if you look at number 1, we're going to use that to find the sides of right triangles. Well, your hypotenuse is always your longest side. It's also, remember, across from your right angle. So my hypotenuse is that 13. Your A and your B are your legs. They're interchangeable. I don't care if you put A here and B here or vice versa. But when you're trying to solve, now we have a squared, which I labeled as 4. It doesn't matter if you flipped it. So 4 squared plus x squared equals 13 squared. Okay, so now we just need to go through and clean up. So we get 16 plus x squared equals 169, and then for math 1, we know how to solve that. We subtract our 16 over, and we get x squared, and you subtract your 16 and you get 153. And then remember, in order to undo a square, you take a square root. So you end up with x being the square root of 153. Well, if you take the square root of 153, it's going to be somewhere between 12 and 13 if you estimate. And it ends up being 12.37-ish. So x is about 12.37. And you guys, that's centimeters. Make sure you get your label on there. And we're going to talk more about this about symbol. We're rounding, which means it's an approximate value, which means you should have a squiggle. It's the same thing as the equal sign, but it's a squiggly line because it's telling you you approximated at some point, and that is not an exact value. Something like 4.5 would be an equal sign. It's an exact value. This worked out to 12.3693, yada, yada, yada. So you rounded at some point, and you need to have the approximate symbol there to signify that. Okay. For number 2, across from the hypotenuse is x, so now we're actually looking for the hypotenuse. Again, a and b are interchangeable. It doesn't matter which one's which. So we have 6 squared plus 15 squared equals x squared. So we end up with 36 plus 225. So we get 261 is x squared. Again, in order to undo that square root, or that square, you take the square root. So you end up with the square root of 261. So if you're going to write it with an equal sign, you're going to write the square root of 261 equals x. That doesn't mean much to people, right? It's going to make more sense when it's an actual number. So that ends up being x is approximately 16.16, and that's feet. You guys get your labels in there and make sure that you have the approximate symbol. Okay, so you're either going to be solving like number 1 for a leg, A or B, they're interchangeable, or like number 2 for the hypotenuse, which is C. Okay, for your homework, you just need to go through those 12 problems. And once you go through those, make sure you check those on Google Drive, see how your answers are, and then we'll go over any questions you have tomorrow. Cool?